So this is the second class for continuity and differentiability, exercise 5.1 we are taking today. And here first question, prove that the function fx is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3, and at x is equal to 5. Three particular points are given to us, and we have to check whether this function is continuous or not. Okay, and then second question is also similar one. The third question, where the points or intervals nothing is given, only definition of the functions are given. So examining the following functions for continuity, and that means we have to check in the domain, isn't it? So that is second kind of questions. And then number 4, prove that the function fx is equal to x to the power n. This is again a polynomial function. A particular point is given, x is equal to n, and is a positive integer. This is not exactly particular, it is a set of integers where we have to check this polynomial function is continuous or not. Number 5, is the function f defined for different subsets of real numbers? Definition of the function is different. Fx is equal to x if x is less than equal to 1, and fx is equal to 5 if x is greater than 1. So one by one we will try to solve, but the similar questions I will skip. Okay, so first question, let us see how can we solve them, isn't it? So your first question here, prove that the function fx is continuous at x is equal to 0. 3 points are given to you, isn't it? x is equal to 0, at x is equal to minus 3, and at x is equal to 5. एक एक करके देखते हैं. ये जो पॉइंट है पर्टिकुलरली एक minus 3, एक 0 है और ये 5 है. रियल नंबर लाइन में मैं ऐसे बड़ा करके दिखा रहा हूँ. आइडिया ले लो कि ये 3 पॉइंट है, ठीक है. Okay, when x is equal to 0, y is equal to minus 3. X, just put here 5 into 0, minus 3, you will get final answer, minus 3. And then fx is equal to 0 means y is equal to 0 means fx is equal to 0. If you put 0, then x is equal to 3 by 5 we will get. And putting these points here and here, points 0.6 means 3 by 5, isn't it? So through joining these 2 points, we will get one straight line. This one. Now you see, when x approaches towards 0, y is getting down to minus 3. So that is for right hand limit of fx when x approaches to 0 positive. From right hand side means limit x tends to 0 positive, 5 of x minus 3, and in place of x we have put 0 because x is approaching 0. So 5 into 0 minus 3, right hand limit of fx is equal to minus 3. Now next let us find out left hand limit. Before that, you see, let us observe what happens. X approaches from left hand side. At the same time, y approaches to minus 3. That's what is represented by this calculation. Limit x tends to 0 negative of fx. X tends to 0 negative, 5 of x minus 3. 5 into 0 minus 3 minus 3. Left hand limit is also minus 3. Now we are left to find out value of fx at 0. So you see, value of function at x is equal to 0 is f0. 5 into 0 minus 3, since fx is equal to 5x minus 3, with what? Ncert giving minus 3 only. That's what. What have we got here? All the 3 quantities, left hand limit, right hand limit, and value of the function at 0 are equal, which is minus 3, isn't it? What can be done with these values? You see here, limit of fx, x tends to 0 negative. For left hand side, we are taking the definition of fx as 5x minus 3, and for right hand limit also, definition of fx is 5x minus 3. So in both cases, we are using the same definition. So in such cases where definition of a function on either side of a point is same, in that kind of cases, not necessary to find the right hand limit and left hand limit separately. That means what I am going to say is that when the definition of fx on either side of a point is same, then we can find the limit of the function straight away without calculating left hand and right hand limit separately. That means you see merged actually, and instead of this this way. Then why did I do that? Because just to know what is inside this mechanism actually. That's what I have explained before working out this portion. Okay. See here, actual answer is this part, and this much is enough for answering. Okay. Here fx is equal to 5x minus 3. That is our question. Therefore, we are going to find the limit. Directly we are finding limit of fx at 0. Okay. So that's how here we are getting minus 3. So the next value of the function is a similar way, f0, 5 into 0 minus 3. Instead of x we are putting 0, then minus 3. That is limit fx x when x tends to 0 equal to f0. Value of the function and the limit, both quantities are equal, which is minus 3. So we can decide that fx is continuous at x is equal to 0. This is what is to be produced in your examination paper. Got it? So previous whatever explanation was just for the sake of making you understand, I explained those things elaborately, and I hope that much is helpful to you. That is helping you to understand this one for checking continuity of fx at minus 3. So for that we are finding left hand limit of fx at minus 3 negative, and that we are having here minus 18. Okay, now you see minus 3 is this point, and y minus 18 means here approximately in this portion. Right hand limit minus 3 positive of fx. Limit x tends to minus 3 positive, 5x minus 3, because definition of fx is 5x minus 3, and then 5 minus 3 instead of x we have put minus 3 minus 18. So right hand limit and left hand limit, in both cases we are having minus 18. And most interesting point is just I am going to say the interesting point in this case, you see definition of fx in both cases we are using 5x minus 3. When I have already told you that when definition of a function in both cases, left hand limit and right hand limit, we use the same definition of fx. In that case, not necessary to find both limits separately. We can straight away find that limit. Taking x tends to 3, minus 3, or x tends to 0, whatever the point is given to us, at that time we can use x tends to that point directly. Not necessary to take positive or negative separately. Got it? You just put some importance on that facts, because that will help. That will be very helpful to you in future, in working out or in checking this kind of continuity. Okay. Now value of the function, the same way, f of minus 3, instead of x you use minus 3, then again result is minus 18. So in three quantities we are having equal value. That means the function is continuous at that point minus 3. We have merged these two because I have explained this much. The real expression for your answer is this part. Okay, I am repeating you that not necessary to find left hand limit and right hand limit separately, because here definition of fx on both sides of minus 3 is same. Got it? I'm not going to write all in details. Just the answer I am giving. Here at x is equal to 5, you understood I think why I am doing this. limit x tends to 5 fx, limit x tends to 5 for fx 5x minus 3. That is the same definition, same question. So x is equal to 5 we have put, and we got 22. Value of the function, limiting value and value both are same, 22, 22. So they are equal, means f is continuous at x is equal to 5. So now you have, I think you have understood how to write or what is continuity of a function at some point, isn't it? So if any doubt, then please comment on the comment box. This next question, I am leaving the second question because they are exactly similar to the first one. Now I am taking question number 3 out of 4. I will work out only one because all these 4 are similar one. Here this question is different from the other question. What we have done is no point is given or no interval, no domain is given, just the definition of the function is given to us. So in this kind of questions, how do you check the continuity? That's what we have to learn. You will learn now to this part, that without when you are not given any point or interval or any domain, then how to approach to solve this, to check the continuity of this kind of questions. Okay, so let us move. We are taking question number B. Here the real number line. This function is defined in the set of real numbers. Every real number can be put here except 5. 5 minus 5 will be 0. And when we put x is equal to 5, then the function will be undefined. And no real value we will get for 5. That's why except 5. For all real numbers, this function is defined. There we will check the continuity of this function. Correct? Okay. All real numbers greater than 5. See, this is moving. This part, we have to check the continuity of the function. Except 5. Here, the function is not defined. That's why all real numbers greater than 5, there we will check, or we will check other parts. See, here in this region, all real numbers less than 5, except 5. I hope you understood where we have to check the continuity of the function. Okay. Now your answer is like this. Let's see, an arbitrary real number is to be considered first here. So when you are going to answer this kind of questions, you first assume any arbitrary real number, but from the domain. Here 5 is out of the domain, so c cannot be equal to 5. Okay, that is what mentioned here. So at x is equal to c, we will find the limit x tends to c. Why don't find the left hand limit and right hand limit separately? Because the definition of the function is same on both sides of x, both sides of c. Whatever real number you consider, you will see that on either side of any real number, the definition is 1 by x minus 5. Okay. So that's why we are finding limit directly. And then value I have got 1 by c minus 5. Okay, this much you understood. To work out this kind of problem, you need some concepts. Whatever you have acquired in class 11, that is required. And I think you know and you have that much. Value of the function at x is equal to c is f of c equal to 1 by c minus 5. Therefore, see, their values, both the quantities are same. 1 by c minus 5, 1 by c minus 5. So therefore, limit x tends to c f x is equal to f of c. Hence, fx is continuous for all real numbers in this set. In the set R minus 5. Okay.